Find the general solution of the differential equation dy dx equals 2x plus 1. So we're looking for a family of functions whose derivative is 2x plus 1. So that would be x squared plus x plus c. Find the solution satisfying y of 1 equals 5. So y of 1 would be 1 squared plus 1 plus c. That equals 5. And then solve for the c and you get 3. That's not the answer to this problem. The answer is a function where I replace the constant with a 3. X squared plus x plus 3. Suppose we know that the second derivative of a function f is 8e to the x plus 12. And I have some initial conditions here about f prime and f. What is f? Well, I know f double prime is 8e to the x plus 12. So I'm going to take an antiderivative to figure out f prime. So the antiderivative of e to the x is e to the x. So this is 8e to the x plus antiderivative of 12 is 12x plus an unknown constant c. To figure out what that c is, I'm going to use my first initial condition. F prime of 0 is 4. So this would be 8 plus 0 plus c equals 4. So c is negative 4. So now I know the final formula for f prime of x is 8e to the x plus 12x minus 4. And then I'm going to repeat this process again to find f. So f of x is an antiderivative of f prime. Antiderivative of 8e to the x is 8e to the x. An antiderivative of 12x is 6x squared. An antiderivative of 4 is 4x, and then there's an unknown constant c that I will solve for using the second initial condition. F of 0 would be 8 plus 0 minus 0 plus c equals 10. So c is 2. Really tempting to circle that and think you're done because you have so much experience solving for an unknown quantity and having that be the answer, but that's just a step on our way to the answer. F of x is this formula, but I replace the c with a 2. So I have 8e to the x plus 6x squared minus 4x plus 2. Okay, on the moon, the acceleration due to gravity is about negative 1.6 meters per second squared. From the top of the moon lander, you throw a rock straight upwards so that its height after 5 seconds is 45 meters and its velocity after 5 seconds is 4 meters per second. Create formulas for each of the following. Okay, so for velocity, I'm going to start with acceleration because they told me that it's negative 1.6 meters per second squared and it's constant. So my velocity is an antiderivative of this, so it will be negative 1.6 t plus c. And I know that my velocity after 5 seconds is negative 1.6 times 5 plus c is 4. So negative 1.6 times 5 is negative 8. So c comes out to be 12, which means that my formula for velocity is negative 1.6 t plus 12. All right, to come up with a formula for the height of the rock, h of t is an antiderivative of velocity. So I have negative 0.8 t squared plus 12t plus c. To solve for c, I know that h of 5 would be negative 0.8 times 5 squared plus 12 times 5 plus c. And that is, they told me 45. Let me pull up a calculator here. Okay, so 25 times negative 0.8 plus 12 times 5 is 60 So that's 40. So c has to be 5. Subtract 40 from both sides, you get c is 5. So then my final formula for h of t is negative 0.8 t squared plus 12t plus 5. Okay, part C, use calculus techniques to find the maximum height of the rock and how long it takes to reach its maximum height. So the maximum height, remember this word maximum, in Calc 1, we find maximums and minimums by taking the derivative and setting it equal to 0. So the derivative of h of t is v of t. So I want to know, when is the velocity equal to 0? And that makes sense. If you throw a rock up, it goes up, 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 and it's slowing down, slowing down, slowing down until it reaches its maximum height, at which case there's one moment where its instantaneous velocity is 0 before it starts falling. So I want to set velocity equal to 0. To solve for t. That will tell me when we hit the maximum height. So 12 over 1.6 is 7.5. 7.5 seconds. It is seconds, right? Yeah, 7.5 seconds. And then that is how long it takes to hit the maximum height. And then what is its maximum height? We're going to plug 7.5 into the height function. So 7.5 squared times negative 0.8 plus 12 times 7.5 plus 5 comes out to 50 meters. 7.5 seconds. Okay, a jet needs to attain a speed of 200 miles per hour to take off. It can accelerate from 0 to 200 in 30 seconds. And we're assuming constant acceleration. So every second, it increases its velocity by the same amount. How long in miles must the runway be? So the hint here is to convert everything to seconds, because I have miles per hour, but then I'm giving another piece of information in seconds. So I want to have my time units all be consistent. So I'm going to convert 200 miles in 1 hour to miles in 1 second. So I need this to cancel. So I need 1 hour on top and an equivalent amount of time on the bottom, which is 3,600 seconds. So 200 over 3,600 is 1/18 of a mile per second. 1/18 miles per second. That is the final speed I need to hit. After 30 seconds, I hit 1/18 of miles per second. So my acceleration is constant, which means it's just the change in the velocity over the change in time. Because it's a constant acceleration, it's a line, it's got constant slope. So my change in velocity is 1/18 miles per second in 30 seconds. So that comes out to, when you simplify, 1 over 540 miles per second squared. Just quickly show you 1/18 divided by 30 divided by 30 seconds, and then change it to a fraction, 1 over 540. So that is my acceleration. My acceleration is constant. So it's 1/540th mile per second squared. I'm not going to write the units down now. Okay, which v of t is an antiderivative of velocity. Sorry, is an antiderivative of acceleration. So 1 over 540 t. And technically there's a plus c here, but v of 0, my initial velocity was 0. I'm going from 0 to 200 miles per hour. So my initial velocity is 0, so this is 1 over 540 times 0 plus c is 0. So c is 0. So this is my formula for v of t. The c is just a 0, 1 over 540 t. So then my formula for position is 1 over 1080 t squared. Technically there's a plus c, but we're going to assume the beginning of the runway is position 0. So at time 0, we're at position 0. So this is 0 plus c is 0. You get c is 0 again. So my position function, s of t, is 1 over 1080 t squared. So I know it's going to take me 30 seconds to reach the speed I need to be going, so I'm going to calculate s of 30. So I pull up my calculator, and I'm going to do 30 squared and divide by 1080 and change it to a fraction, and I get 5/6. 5/6 of a mile.